All right. Good morning, everybody. It is 9:16. 9 and 16 are both perfect squares, right? Because 3 times 3 is 9, and 4 times 4 is 16. Ayo! All right. So today we're going to be working with representing large numbers using exponents. Okay. Oh my God, I love this song. Okay. Anywho, so this is 10 to the 7th. Okay. This is the same thing as 10 times 10 times 10. Well, you get the idea, right? So, just to give you a heads up, this number on the number line is 9 times 10 to the what power, though? Is it going to be 7 or 6? Remember, the number's to the left of it. So, should it be bigger or smaller? Your pictures are falling down to the 6th, right? Because that has to be smaller. It's going to be 8 times 10 to the 6th. Go ahead and work on the other ones. Step, step, and retrace the sad look on your face, the timing. 5 times 10 to the 6th. 4 times 10 to the 6th. 3 times 10 to the 6th. 2 times 10 to the 6th. 1 times 10 to the 6th. And then this is technically 0 times 10 to the 6th, haha, which is also known as 0, okay? So now we want to place these numbers on the number line. Well, I guess this is growing up. So that's going to be 4 times 10 to the what power, though? Like, how many zeros do you see? 6? Yep, I agree. So, whee! That's where this number goes. What about this one? 5 times 10 to the 6th. When he's gone, I won't come back. That'll happen once again. You'll turn to a friend, someone that understands, sticks to the master plan. But everybody's gone, and I've been here for too long. The face is on my own. Well, I guess this is growing up. So let's look at this number, okay? So that's 5 followed by 1, 2, 3, 4, 5 zeros, okay? So if we wanted to write this number with an exponent of 6, right? Because we want to write this as something times 10 to the 6th. So that means we're going to count we're going to count the decimals. 1, 2, 3, 4, 5, 6? No. What am I trying to do here? I know, okay, here's the thing. I know this is technically 0.5 times 10 to the 6th. Because when you multiply it by 10, you move the decimal over to the right, and then it just becomes 5 times 10 to the 5th. 0.5 times 10 to the 6th. So 0.5 is halfway, right, between 1 and 0. So this is going to be 0.5 times 10 to the 6th. Let's use purple now. So 75 times 10 to the 5th. Once again, this is going to be 7.5 times 10 to the 6th. 7.5 is between 7 and 8. And then last one, oh, we get to pick our own color? Let's do whatever the heck this color is. Baby blue. 0.6 times 10 to the 7th. We can move, well, let's see. 0.6 times 10 to the 7th. It's going to be 0.6 times 10 times 10 to the 6th. This right here is 6. So that's just another way to say 6 times 10 to the 6th. That's where the numbers fall. Okay, so we can't do this one because you can't trade. Which is larger, 4,075,000 or 75 times 10 to the 5th? So they're asking us about A and D. So let's just look for red and purple. So which one's bigger? Yeah, purple. And yesterday I thought of you, left me with things as if I couldn't walk away. So if you want to figure out how many times larger one number is over the other, you can just divide. Okay? Now, cool thing, these cancel, these cancel, these cancel, these cancel, these cancel. So now you have 75 over 40. And I can tell you that's 1 and 35/40ths. 35 over 40, both of those numbers are divisible by 5. So you can divide both the numerator and the denominator by 5. So you get 7 over 8. I know that 7/8 is 0.875 as a decimal. So it's 1.875 times bigger. I just got a text, or what did I get? Yep, I know, baseball. Today was supposed to be opening day for the Oakland Athletics, but anywho, the table shows how fast light, waves, or electricity can travel through different materials. I don't know if y'all know this, but like light can travel through many different materials, but through some materials it travels faster than others. So if we just look at light waves, it can travel 300 million meters per second in space. In water, it actually slows down. Okay, so which is faster? Light through diamond or light through ice? So does it travel faster through diamonds? Can't draw diamonds. Or through ice? Ice. Ooh, I'm losing my voice there. How can you tell? So let's zoom in to highlight the values between 2.0 times 10 to the 8th and 3.0 times 10 to the 8th. Label the tick marks 2.0 times 10 to the 8th and 3.0 times 10 to the 8th. So it says plot a point for each speed on both numbered lines and label it with the corresponding material. Oh, they want us to graph them. Ha ha ha. So there's this one here. Okay. So let's do the math work over here. Okay. 124 times 10 to the 6th. If we're going to move the decimal over, right, the decimal's technically there. If we move it twice to the left, this means we're going to have to increase the exponent by 2. 1.24 times 10 to the 8th, and that's diamond. The other one is ice. Oh, that's already written there for us. 2.3 times 10 to the 8th, and that's ice. Okay? So, let's see. Diamond, wait, it's 1.24 times 10 to the 8th. That doesn't make any sense. That really does not make any sense. Well, anywho, if we look at ice, right, this would be 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and then 3.0. So ice would be right here. But diamond is smaller than ice. So diamond would be somewhere like 1.24. It would be like over here. So which one's bigger, ice or diamond? Light travels faster through ice or diamonds? Ice. Which is faster? Oh, we already said that. How can you tell from the number line? Light travels faster through ice because it is further on the right. Let's not worry for this right now. You can try it out on your own, actually. What? No, let's try it out then. Find a 4-digit number using only the digits 1, 2, 3, or 4, where, okay, so it's a 4-digit number, and you know what? 3, 2, 1, and it can't be a 0 because you can't have a 0 in the thousands place. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. The first digit tells you how many zeros are in the number. Okay? The second digit tells you how many ones are in the number. The fourth digit tells you how many threes are in the number. What? This should have been a math puzzle of the week. Yeah, I'm gonna let you work on this for fun. And if we look at the summary, there are many ways to compare two quantities, two big numbers. Suppose we want to compare the world population, which is that was last year, 7.4 billion people, to the number of pennies the US has made in 2015, which is this amount. Notice how this is a decimal followed by a word, and then this right here is just a number. So how do you know which one's bigger? It would help out if you wrote out both numbers, or you can use exponential notation to figure out which one is bigger. And if you notice, the number of pennies is bigger. And visually speaking, this is how many times, where they would fall on a number line. Right, people was 7.4 times 10 to the 9th, and pennies is 8.9 times 10 to the 9th. So notice how 7.4 is after 7, but before 8, right, 7.4. And then 8.9 is after 8, but it's before 9, and it's closer to 9, obviously, because it's 8.9. So let's look at the practice problems. There's not that many. We good. So find 3 different ways to write the number 437 using powers of 10. So the easiest one, in my opinion, would be, 437 times 10 to the 3 zeros. And if you move the decimal once to the left, it increases the exponent. So doing this again, 4.37 times 10 to the 5th. For each pair of numbers below, circle the number that is greater. Estimate how many times bigger. Okay, so which one's bigger? 17 times 10 to the 8th or 4 times 10 to the 8th? Yep. And how many times bigger? About 4 times. Right, because you could also do the bigger number divided by the smaller number. These would cancel, so you just have 17 over 4, which is actually 4.25. Which one's bigger? I agree. And how many times bigger? About 4 times as well. And if you really wanted to figure out, you could do this. And then whatever the heck 7.839 divided by 2 would be your answer. And then this one, Remember, if we move the decimal to the left, we can convert this to 4.2 times 10 to the 8th. Now which one's bigger? (8.5 times 10 to the 8th. And how many times bigger is it? About 2 times. Ooh, what number is represented by point A? Explain how show how you work. So if this is 10 to the 12th, what is this number going to be? 9 times 10 to the 11th. This is going to be 8 times 10 to the 11th. This is going to be 7 times 10 to the 11th. 6 times 10 to the 11th. 5, 4, 3, 2, 1 times 10 to the 11th. 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 Now, if we zoom in on this portion here, this number is 7 times 10 to the 11th. And this number is 8 times 10 to the 11th. So this is going to be 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, 7.9. I'm not going to write the exponents, okay? But what number does it represent? 7.4 times 10 to the 11th. Now, number 4 is kind of difficult because that's technically Unit 6 material. Except, actually, I should say this. For those of you who have passed or taken the additional focus area, associations and data, you know, does this look like it's linear? Does the data, right, the data points, do they look linear? I agree. Does it look non-linear? I agree. Sorry, non-linear as in like is it not a line? Yes. No, sorry. No, it's not a line. No, wait. It's linear. Okay, it looks like a line. Is it increasing or decreasing? Is it a positive or negative? It's a positive, right? And automatically, because there is an association, this can get rid of, and it's positive, so it can't be negative. So this is a positive linear. So here's a graph of days and predicted number of hours of sunlight on the 10th day of the year. So this is the 10th day of the year, right? So here's your first day of the year, 50th, 100th, 150, 200, 250, 300, 350th, and then guess what number this is? 364. And this is how many hours of sunlight. So each day there's 24 hours in a day, right? So it makes sense that the y-axis goes as high as 24. So this actually looks pretty cool. Notice how this graph has like a little hump. You're actually going to learn about these types of graphs in pre-calculus. Some people actually learn these in Algebra 2, which is the class you take right after geometry. Or you might see this in a special class called trigonometry. They're called sinusoidal functions. And they just look like this. So like if you're ever in a hospital and you hear the little machine goes beep, 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 that's literally one of these graphs right here. Anywho, let's look at what it's asking. Is hours of sunlight a function of the days of the year? Yes. Because if we know the time of the year, we can predict hours of sunlight. Right? It's a lot easier to say, hey, we're in May. How many days, hours of sunlight are we going to get? Oh, that's easy because we know where the sun is. But if I were to tell you, hey, we had 12 hours of sunlight, do you know what day it is? No, we don't. For what days of the year is the number of hours of sunlight increasing? For what days of the year is the number of hours decreasing? I'm going to use colors here, okay? Blue for increasing and red for decreasing. So, where on this graph is it increasing? This is like Dora or like Elmo. Show me on the screen where the number of hours is increasing. Correct! This is increasing, right? Notice how the values are going up. Now show me where the values are decreasing. Oh, that's kind of weird. Great! Yep. And then for a bonus question, let's use green. Where's the maximum amount of daylight? Right here. And it's approximately 16, 17, 18, 19 hours of sunlight. That means only 5 hours of nighttime. Do y'all know when this actually happens? Like, what part of the year this happens around? During the summer. Because that's when the earth is tilted in a way where we get a lot of sunlight. And that's why it gets hot during the summer, because we have much more sunlight. And on the other side of the world, right now we're getting maximum sunlight. On the other side of the world, it actually looks like this. They're getting very little sunlight. Anywho, that's your homework. I hope y'all are having a fantastic time. Some of you are not submitting your assignments. Just go ahead and click submit, so that tells me that you're actually working on these. My last video only has about 2 views, which means some of you are lagging it. Okay, it's pretty obvious, unless you're working on this without any video support. But anyways, yeah, right now we're not gonna see y'all until May 5th, so Cinco de Mayo, or is it May 4th? May the 4th be with